Hello dear students. So in this video we will be discussing gravitation PYQ from January 2024 attempt. Before this we have also discussed April attempt PYQ and other chapter PYQs also we have discussed, like your kinematics, NLM, work energy, ray optics, electrostatics. The link for all the PYQ videos you will find in the description box. So now let us start with this video. So the first question that we have, it is your 27 January shift 1 question. It says the acceleration due to gravity on the surface of earth is g. Fine. On the surface of earth, g is given. If the diameter of earth is reduced to half of its original value and mass remains constant. So diameter, let's say d dash, the new diameter is made half, which is d by 2, and mass is constant. So m dash is m only. Fine. Then the acceleration due to gravity on the surface of earth would be, fine. Let's solve it. So let's say that from g it changes to g dash when your diameter is changed, right? What is our value of g? What is our relation for g? We know g is given as capital G me by re square, right? If we change the diameter, radius will change, right? And therefore your g value will also change. So g dash, what can I write? G dash will be capital G. Mass is mass is constant only, so this will be g me by radius re. If diameter is made half, radius will also become half, so this one will be your re by 2 whole square. If we simplify this, we get g dash is equals to 4 times capital G me by re square, which is equals to 4 times g, right? So the new g value is 4 times g. Let's move ahead. Okay, second question, it's an assertion reason question. Let's look at the statements. Assertion says the angular speed of moon in its orbit about the earth is more than angular speed of earth in its orbit about sun. Fine. They are talking about your basically omega, right? What is our omega relation? Omega is 2 pi by t, right? Omega is 2 pi by t. So from this we can say that omega is inversely proportional to time period. The one will have, the body which has more time period will have less omega, right? And from our understanding, if we consider earth and moon, moon around earth and earth around sun, which one has more time period? Earth takes more time period to revolve around the sun, and therefore omega for earth will be less than omega for moon, right? Is this thing given to us? The angular speed of moon in its orbit about the earth is more than your earth. Fine. Let's look at the reasoning. The moon takes less time to move around the earth than the time taken by earth to move around the sun. So I think statement 1 is right. That means assertion is right. Reasoning statement is correct. And it is the right reason also, right? Option will be your option number 2. Both A and R correct, and R is the correct explanation of A. Fine. A planet takes 200 days to complete one revolution around the sun. Fine. If the distance of the planet from the sun is reduced to 1/4 of the original distance, how many days will it take to complete one revolution? So basically, if the distance of the planet from the sun is changed, how your time period changes? What is the relation we know? We know that t square is proportional to r cube. I hope this point is okay, right? Time period square is equals to your r cube. Now initially time period is given to us 200 days. Let's say the distance was r1. When the distance is made 1/4, that means r2 is made r1 by 4, we have to find out time period. This is what is given to us. Let's substitute over here. So from this, what can we write it? T1 square by T2 square is equals to R1 cube by R2 cube. Substituting values over here, T1 is 200 whole square by T2 square is equals to R1 cube by R2 cube, and R2 is what? R1 by 4, 1/4. So this one will be r1 cube into 4 cube, this will be 64. Cancels out. We have T2 square is equals to 200 square by 64. So T2 time period comes out to be 200 by 8, which is 25. So 25 days will be our answer. Let's move ahead. Yes, so the next question that we have, it says the gravitational potential at a point above the surface of Earth is minus 5.12 into 10 power 7 joule per kg, and acceleration due to gravity at that point is 6.4 meter per second square. So V value is given to us minus 5.12 into 10 power 7 joule per kg, and G, acceleration due to gravity, is 6.4 meter per second square. Fine. Assume that the mean radius of Earth is 6400 kilometer. The height of the point above the Earth's surface is, fine. Let's solve it. So what we'll have, V relation from the Earth's surface. If we consider a height h, what is our V relation? We write potential is given as minus gm by r plus h. R over here is radius of Earth, right? Let's substitute this. So minus 5.12 into 10 power 7 is equals to minus gm by r plus h. Okay, equation 1. Now G, acceleration due to gravity at height h. Acceleration due to gravity will be gm by distance from the center, that is your r plus h whole square. If we substitute, 6.4 is equals to gm by r plus h whole square. Equation number 2. If we simplify them, 1 and 2, let's do 1 by 2. So if we do 1 by 2, we'll have 5.12 into 10 power 7 divided by 6.4 is equals to r plus h whole square by r plus h. R plus h whole square by r plus h. Cancels out. We have over here 10 power 2. This will be your 10 power 8. So 64, we have 8 times. This one will be your 8 into 10 power 6 is equals to r plus h, right? Let us substitute value of r. Now beta, in the question r is given to us as 6400 kilometer, which is basically, it's visible to you here. I'll do here. R is given to you 6400 kilometer, which we can write as 6400 into 10 power 3 meter, which will be 64 into 10 power 5 meter. I hope this is okay, right? Let's substitute over there. So 80 into 10 power 5 is equals to 64 into 10 power 5 plus h. H value will be 80 into 10 power 5 minus 64 into 10 power 5. This will give us 16 into 10 power 5 is equals to h. 16 into 10 power 5, this one I can write as 1600 into 10 power 3 meter is equals to h. Therefore h value comes out 1600 kilometer, right? Check the option. Options are there for you. Option will be option number 1. Option number 1 will be our correct answer. Let's move to the next question. Okay, so the next question we have, it says escape velocity of a body from Earth is 11.2 kilometer per second. It's a standard result. We know escape velocity from Earth's surface is 11.2 kilometer per second. Fine. If the radius of a planet be one third the radius of Earth and mass be 1/6 that of Earth. So radius of planet is 1/3 of the radius of Earth, and mass of planet is 1/6 of the mass of Earth. This is what is data given to us. Fine. The escape velocity from the planet is, how to deal with it? What is our escape velocity relation? Escape velocity is given as root over 2gm by r. If it is Earth, it will come out to be me by re. If it is planet, for a planet, what can we write? Escape velocity from any planet, it will be root over 2gmp by rp. This value is given to us as 11.2 kilometer per second. This is a standard result also, we know this. Now over here, if we substitute escape velocity from planet, this is equals to root over 2gmp. MP, mass of planet is 1/6 times mass of Earth, so me by 6, and RP is radius of planet is 1 by 3 times radius of Earth. So RE by 3 cancels out. Ultimately we get 1 by root 2 root over 2g ME by RP, right? Root over 2g ME by RP is nothing but 11.2 kilometer per second. So finally I can take over here, escape velocity on the planet will be 1 by root 2 times 11.2 kilometer per second, right? If you simplify this, root 2 is 1.41, so we can write it 11.2 by 1.41. This will come out to be your 7.9 kilometer per second. Fine, let's move ahead. Okay, so the question that is given to us is 4 identical particles of mass m are kept at the 4 corners of a square. Let's draw the situation. So square, 4 identical particles are kept at the corners. That is mass, let's say m, m, m and m. Fine. Okay, if the gravitational force exerted on one of the masses by other masses is 2 root 2 plus 1 by 32 g m square by L square. So on any one of them, force applied, gravitational force applied by the remaining 3 is 2 root 2 plus 1 by 32 into g m square by L square. Fine. The length of the sides of square is fine. Now see over here how to deal with it. This is the force given to us. Let us find out force and then compare it with this relation. So for ease, what we'll do is we'll name them A, B, C and D. Let's write down, let us first draw the direction of force which is acting on particle A, and particle A due to remaining. What will be the direction? It is gravitational force, attractive force on A due to B, right? Okay. Next, force applied on A due to C. It will be along the line joining. This will be force on A due to C. Next, over here, this will be force on A due to D. I hope this is okay. This is the direction. So we have to find the resultant of these 3 forces, that is FAB, FAC and FAD. We have to find the resultant and then equate it equals to this result. So one by one, let's write the relation also. Magnitude of the force. Force on A due to B, how much it will be? G m square, that is g m square by separation square. Now this square, let's say we have side is A. We are assuming side is A, right? We have to calculate the side of the square. So let's assume that side is A. So g m square by A square. Fine. FAC will be g m square by A. This is A, this is A. Separation, this one will be root 2A. So root 2A whole square, that is 2A square. FAD will be g m square by A square. What are the directions? Directions are, this is your FAB, this is your FAD, and over here we have FAC, right? For a moment, ignore this. First of all, let's calculate the resultant of FAB and FAD. Now, if you look at the result, FAB is g m square by A square, FAD is g m square by A square. Let's call this as F, and this also, because magnitude wise both are same only. So for ease of calculation, let's call this as F. What will be the resultant of this? By parallelogram law, we can say that the resultant of FAB and FAD will come along the diagonal, and the resultant will be, which I am calling as F dash, will be root over FAB square plus FAD square plus 2 FAB FAD cos 90. Angle between them is 90, or directly also you can write the resultant of two perpendicular vector is root over A square plus B square. So this thing anyways becomes 0. Ultimately we have root over F square plus F square. What do we get? F dash is root 2F. This is your F dash. F dash is over here, and F dash is coming along the diagonal. Why along the diagonal? Because this is magnitude wise they are same only, so this angle, resultant angle, will be 45 degree only, right? And we also know that FAC is also along the diagonal. So our net force will be, F net will be visible, yes, F net will be F dash plus FAC. Let's substitute root 2 times F, that is g m square by A square, plus FAC gm square by 2a square. If we simplify this, we get gm square by a square. We have over here root 2 plus 1 by 2. This is our net force coming, right? Okay, this is our net force coming. Let's equate it to the result that is given to us. So this, I can further simplify this thing as gm square by 2a square 2 root 2 plus 1, right? 2 root 2 plus 1. This is what we are getting. Now, if we, this is the result that is given to us. If we compare these two results, what can we write in the denominator? From denominator, we can say that 32L square is equals to 2A square. 32L square is equals to 2A square 16 times. So 16L square is equals to A square. That implies 4L is equals to A. What is your side of the square? A, which we assumed A as. So the side of square is coming equals to 4L, right? Option you can check. Option number 2 will be your correct answer. Let's move ahead. Yeah. The question we have is, the mass of moon is 1 by 144 times the mass of planet. Fine. Mass of moon is 1 by 144 times mass of planet, and its diameter of moon is 1 by 16 times the diameter of a planet. 1 by 16 times diameter of planet. We can say radius will also be same. So radius of moon will be 1 by 16 times radius of planet. Fine. If the escape velocity of the planet is v, the escape velocity on the moon is, fine. Escape velocity question, it is kind of same as what we did 2 questions before, 2-3 questions ago. What is our escape velocity result? Escape velocity result will be root over 2gmp by rp for the planet. This is what we write it, and this is given to us in question as v. For the moon, we can write escape velocity on moon will be root over 2g mass of moon by radius of moon. Let's substitute the terms what are given to us. 2g mass of moon. Mass of moon is 1 by 44 times mass of planet. Mass of planet by 1 by 44, and radius of moon. Radius of moon is 1 by 16 times radius of planet. So rp 1 by 16 times. So if we solve it, this thing comes out 9 times. We'll get it 2g mp by rp. This is 9 is also there, so we'll get 9 out of the root. We have 2g mp by rp. How much is this value given to us? V. Ultimately, velocity escape of moon comes out to be v by 3. Okay, v by 3 is our answer. Yeah, the question we have, it says, if r is the radius of earth and acceleration due to gravity on the surface of earth is g, which is equals to pi square meter per second square. Fine, g value is given to us as pi square. Wherever required, take g as pi square. Then the length of second's pendulum at a height of h equals to 2r from the surface of earth is h equals to 2r at h equals to 2r. What is the length of second's pendulum? What do we understand by second's pendulum, beta? Second's pendulum time period is 2 seconds. Second's pendulum time period is 2 seconds, but not on the surface. Means in the situation, in the question, they have not given on the surface. They have said that it is at a, we have to find when it is at a height of 2r. When it is at a height of 2r. Fine. What is our time period of a pendulum? 2 pi by root over L by g. When we move it from the surface of earth, obviously if we take it at a height, g value will change. So this one g value will change. Let's say that at a height of 2r, it becomes g dash. Can we calculate g dash? Yes, g dash will be g times r by r plus h. How much is h? 2r. 2r whole square. So g dash is equals to g times r by 3r whole square. R cancels, we get g by 9. So our g dash value, that is at a height of 2r, g dash value, acceleration due to gravity is coming as g by 9. Now let's substitute. So time period is 2 pi by root over L by g dash. G dash is g by 9. So if I substitute g by 9, right? We want to find out L value. So for L, what can we do it? We'll square it on both sides. We'll get over here T square is equals to 4 pi square into 9L by G. And in the question they have given that take G as pi square. So pi square G cancels out. T square, time period of second pendulum is 2. So 2 will be, this is 4 into 9L by, this is gone already, fine. 4 and 4 cancel. So L value comes out to be 1 by 9. 1 by 9 is our answer. Yeah. So the question that we have is, it says a light planet is revolving around a massive star in a circular orbit of radius r. Fine. So let's say a light planet is moving in a circular orbit of radius r. Fine. With a time period of revolution t, capital T, if the force of attraction between planet and star is proportional to r power minus 3 by 2, that means force is proportional to r power minus 3 by 2, then the correct option is, they are asking us relation between, that is proportionality for time period. Okay, how to deal with it? So beta time period, we know time period is 2 pi by omega or 2 pi r by v, right? If somehow we can find out v or omega in terms of r, we will get our time period proportionality with r. So how to deal with it? This force we can write as k r power minus 3 by 2, constant over here, right? Proportionality. So F is equals to k by r power 3 by 2. Okay. This force is providing the necessary centripetal force. What is our centripetal force? F is equals to mv square by r. Let's substitute k by r power 3 by 2 is equals to mv square by r. M is constant over here, r power 3 by 2, r. Ultimately what will be getting? K by r power 1 by 2 is equals to mv square. This we can write it, v square is equals to c by r power 1 by 2. Okay, v, if we take square root over here, v will be c by r power 1 by 4, right? So we have got v is equals to some constant c by r power 1 by 4. If we substitute over here, we will get over here t is equals to 2 pi r by, v is basically c by r power 1 by 4. All this is constant, so t is equals to some constant k into r power 5 by 4. T square and r, if we square on both sides, we will be getting t square is equals to k times r power 5 by 2. Therefore t square is proportional to r power 5 by 2. This will be our answer. You can check the option, t square and r, what we are having, t square proportional to r power 5 by 2, that is option number A, right? Option number 1. Fine. I hope you found the video helpful. Thank you very much. Bye bye.